Okay, hi there. Today I'm going to be looking at sequences for pre-calculus. Um, I've already gone through some of this stuff with you guys in class, but let me quickly just do a recap of what I've done. I showed you already about factorial and how factorial is that exclamation point. And what that means is if I have, for example, 5 factorial, it means I'm taking the numbers 5 all the way down to 1 and multiplying them together. Okay, so 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 120, etc., etc. You can also take some like this where you expand them out, and rather than going all the way down to 1, you can stop at whatever number's in the denominator, like 21 in this case, and then cancel out. So you end up multiplying 3 numbers together instead of doing the whole thing out. Also, there should be buttons on your calculator. Usually it's X and then an exclamation point for factorial. Being good to be able to figure out how to use that because these numbers get big quick. So there's a couple more examples we went through there. The n and n minus 1, instead of going 100, 99, 98, you're going n minus 1, n minus 2, and you can cancel some stuff out and see what's left. If you start with n plus 1 and subtract 1, you get n, and then if you go to the next one, you get n minus 1, n minus 2, dot, dot, dot. All right, anyway, so I did a few of those, and if you didn't get that, then come see me. This is what's called a factorial sequence, which is 0 factorial, then 1 factorial. 0 factorial is 1, all right, that's the oddball one. 1 factorial, 2 factorial, 3 factorial, which will give you 1, 1, 2, 6, 24, etc., etc. Okay. Then we got into explicit formulas here, where we said write the first 5 numbers of each sequence, where we plugged in 1, 2, 3, 4, 5 in here into 7n plus 2. So 7 times 1 minus 2 is 5. 7 times 2 minus 2 is 12. 7 times 3 minus 2 is 19. 7 times 4 minus 2 is 26. So these will be the numbers in the sequence. Okay. We did this one, which is a little more complicated, where you plug in 1. You got to plug in 1 in 2 places because there's 2 n's. And then you plug in 2 in 2 places, and 3 in 2 places, etc., etc. And I got down to here. So I started talking a little bit about this in class with if you take negative 1 to the nth power, if I plug in 1, I get a negative number. If I plug in 2, I get a positive number because negative 1 to the second power is negative 1 times negative 1, which is positive 1. So you get this alternating sequence where it's positive, negative, positive, negative, positive, negative. And that's going to be important going forward because there's a lot of these that follow that pattern. Okay, so here we go. Find the first 5 numbers of the sequence. So if I take this one and I plug in 1, I get negative 1. Right, a of 1, which represents the first number in the sequence. I get negative 1. 1 plus 1 is 2 over 1 squared, which of course that will give me negative 1. When I look at the second number, sorry, that should have been positive 1 because negative 1 squared over 1 squared is positive 1. All right, if I plug in 2, the numerator is going to be n plus 1, which will be 3. So it's going to be a negative number. And then the denominator will be 2 squared, which is 4. So this is negative 1/4. Okay, a of 3. A of 3 is going to be when I plug in 3 here and 3 down here. Change colors. So I get 9 in the denominator. Numerator is going to be even exponent, so that's positive. When I change this to 4 and that to 4, so this is going to be negative. It alternates positive, negative, positive, negative. 4 squared is 16. We get negative 1/16. And the next one will be positive. It'll be 1 over 5 squared, which will be positive 1 over 25. So the denominators are pretty easy. All right, there's that one. This one, a little bit similar in some ways. If I take negative 1 to that power plus 1, and I'm looking for the first number, second number, third number, fourth number, and last but not least, fifth number. Okay, so if I plug in 1, numerator is negative, and then it's going to be 1 plus 1 is 2, gives me 1/2, negative 1/2. Next one's going to be positive. It's going to be positive, negative, positive, negative. I mean, I can just do that right now if you want. So that gives me positive number, put a plus, negative. The fifth one will also be negative, but the fourth one will be positive. All right, so I've already taken care of the numerator actually, and now I'm just going to be going in order in the denominator. So if I plug in 2, I get 1/3. Next one will be 1/4. Fourth one will be 1/5 because I'm just adding 1, 1/6. There you go. There's your first 5 numbers in the sequence. Number 5. So if I take 16, so this has to do with the exponents. So once again, it's going to go positive, negative, because you're taking a negative number to an exponent. Okay, A1, A2, A3, A4. Okay, so it's if I plug in 1 here, I get 0. Anything to 0 power is 1, which means you're taking 1 and multiplying it by 16, which is 16. If I plug in 2, I go 2 minus 1 is the first power. Anything to the first power is itself. So that's negative 1/2 times 16. And it's going to be negative half of 16 is 8. If I plug in 3, I get squared, which means I get an even exponent, so it's positive. All the ones with 3, these will be positive. These are going to be, anything with an even number I'm plugging in will be negative. Okay. All right, so back to 3. So I get 3 minus 1 is 2, which means I'm taking 1/2 to the second power, so you'd square the numerator, which would be 1, square the denominator would be 4, so I get 16/4. If I plug in 4, 4 minus 1 is 3, so the denominator is going to be 2 to the third power, which is 8, so 16/8, which is negative 2. If I plug in 5, 5 minus 1 is 4, so 2 to the fourth power is 4 times 4, which is 16, so 16 times 1/16 is 1, and then it's going to be positive 1. Okay, so there's your first 5 numbers in that sequence. Next one. So here's the, we're going to look at this in this video and then some in the next one also. For an arithmetic sequence, which is really like a linear sequence, and you can tell whether it's linear or not, or arithmetic, by looking at the pattern. And if you add or subtract the same number over and over, that would be arithmetic, okay? There's also what's called geometric, which is different. We'll get to that later on, hopefully, if there's time in the course. And geometric is when you multiply or divide over and over and over again, all right? So anyway, let me show you what this formula is. Okay, so this is the formula right here. A of n equals A of 1 plus n minus 1 times d. You're welcome to write that on your formula sheets. So A of 1 is the first number in the sequence. D is what we call the common difference. I'll get to what that is. And then A of n is the nth term. So an n is whatever number in the sequence. For example, third number in the sequence would be equal 3. So if I plug in 3, just like I was finding the first 5, n would have been 1, 2, 3, 4, 5. All right, in the last couple problems, that is. So if I'm looking at this one, let me show you this one. If I go, this is a nice easy sequence, 1, 3, 5, 7. The common difference is 2, all right? You can always take the second number minus the first number is one way to do it if it's, a little more complicated. This one's pretty straightforward. If you look at the pattern, you're adding 2 over and over again. Common difference can be negative sometimes. If it was going the other direction, 9, 7, 5, 3, 1, common difference then would be negative 2. In this case, they're getting bigger and bigger, so it's a positive number, and you're adding 2 over and over again. So D is 2. So I plugged D into the formula here right there, all right? And then I plugged in 1 here in the front, whoops, 1 here in the front because it's the first number in the sequence, so I plugged it in for A of 1. So A of 1 is 1, D is 2. I plug that into the formula and I get 1 plus n minus 1 times 2. Now I do distributive property. I multiply the 2 times both of those things. I know it's on the right side. You're used to seeing it on the left, but that's the way the formula is. Figured I wouldn't mess with it. And I get 1 plus 2n minus 2. And if you simplify that, this is the equation we're looking for. That's also called the explicit formula, all right, because it's the best one, and I can find out anything I want. If they ask me what the 200th number in the sequence is, I can plug in 2 for n and find out what the 200th number in the sequence is. It's a linear equation, so there's the slope is what's in front of the n, or the x, if you change it to x's. The y-intercept is the lone number at the end there. You know, it's linear, so keep that in mind as you go forward, because it could help. All right, so this one. If I'm looking for the equation for this one, it's also called the nth term of the sequence, which is the A of n formula. Either way, that's what they're looking for. And I wrote that up here. What is the expression for the nth term of the sequence? So that's the same idea as looking for the explicit formula. All right. If I take this equation, I know what D is. D is 4 because it goes 2, 6, 10. You can subtract 2 from 6 and get 4. A of 1 is the first number in the sequence, which is 2. Now I can plug it into the formula. A of 1 is 2 plus n minus 1 times the common difference, and then just simplify. 4 times 1, 4n minus 4, and if I simplify, combine a couple terms together, I get A of n equals 4n minus 2, and there it is. Okay? Next one, why don't you try this one? See if you can come up with the A of n formula, which is also called explicit. Okay, and I'll show you the answer in a minute, so if you want to try it out, come back, hit pause now. Okay, so here's the answer for that one. Hopefully you got that. So then we also have some of these non-arithmetic sequences where you just kind of have to figure it out, okay? You look at the pattern, see what's going on. In this one, you know, it's a fraction, so I'm going to make a fraction bar. The numerator, that's not too complicated. It's doubling over and over again, which means, you know, it's going powers of 2, okay? 2 to the n would give me that. Now, the only thing is that if I plug in, you always plug in 1 first for n, which means if I plug it in, I get the second number in the sequence, not the first one. But if I plug in 2, I'll get the 4, and if I plug in 3, I'll get the 8. So I have the right number, but I'm off by 1, which means I'd like to move over here to 1 prior, which means often if you just go minus 1 there, that'll get you 1 to the left. And now if I plug in 1, I get 2 to the 0 power, which is 1. Okay, anything to the 0 is 1, except for 0 to the 0 is 0. And now I've got the correct thing in the numerator. Denominator, those are powers of 3, which means if I take 3 to the first power, I'll get 3. 3 to the second power will give me 9. So this is 3 to the n. And let's see, do I get the right number? If I go plug in 1, I get the first number in the sequence. Oh, that one works, so I don't have to subtract. It didn't start with 1, so I don't have to subtract 1 from the exponent. So that's your explicit formula. All right, now I can find anything I want. If they ask me with a 20th number in the sequence, I can just plug in 20. All right, so that's what I was looking for. All right, number 10. Oops. This one, what's the A of n formula for this one? All right, so once again, it's a fraction. Denominator, 1, 2, 3, 4, 5, or just up to 4. So the denominator is nice and easy. It's just going up by 1. It starts at 1, so I can put n. N will then be 1, 2, 3, 4, 5. the numerator also goes up by 1, so that one's close to n. However, it starts with 2 instead of 1, which means I'm just going to add 1 to it. And then if I plug in 1, I get 2. If I plug in 2, I get 3. If I plug in 4, I get 5. And now I'm good. And that's the A of n formula there. Okay. This one, a little different. Alternating. We got that alternating pattern again. So if I take this, -1, and I take it to the nth power, I'll get that alternating positive-negative sequence, because -1 squared is +1, -1 to the third power is negative, -1 to the fourth power is positive. Okay, now the only question is do I want to add 1 to the exponent or subtract 1? It's really the same thing in this case. Or is it good the way it is? If I plug in 1, do I get a negative number? Yeah, I do. If I plug in 2, do I get a positive number like I have up on the screen there? Yes, I do. All right, so I'm good. Otherwise, you'd probably go -1 up here. And that would give me the first number being positive, second being negative. But in this case, I don't have to. All right, so I got that. Now I got to figure out what the pattern is. So it's 2. These are the powers of 2. 2, 4, 8, 16, doubling over and over again, which means it's 2 to the nth power. And if I plug in 1 now for n, do I get the first number in the sequence? Yeah, I do. If I plug in 2, do I get the second number? Yeah, I do. This is your A of n formula. This also can be written, just so you know, -2 to the nth power, like that. All right, so either one would work in this case. And if you play with it for a minute, you will see that. Okay. So that was number 11. Number 12. Similar, positive, negative, positive, negative. So let me start with this. So if I go like this, if I plug in 1 now, I get a negative number first, and I want it to be a positive one. So here's where I subtract 1 from the exponent, or add 1. Maybe I'll add 1. Because then you get 2, which in your mind will give you -1 squared. It's probably easier than the 0 power. But anyway, so now I got the negative, positive alternating sequence. Now I've got to figure out what the rest of it is. 3, 9, 27, 81. Well, those are powers of 3. So if I go 3 to the nth power, that will give me 3, 9, 27. And if I plug in 4, I get 81. Okay, so I'm good there. And I got the positive, negative. This is also not the only way to write the formula. It could be, trying to think here. So if I plug in 1, I'll get the first one being negative. So actually this one, you don't really want to do what I did in the last one, where I go -3 to the n, because if I do this, I get -3 for the first number, not +3. Okay, so I wouldn't go changing that one around. I'm just going to leave it like that instead. Okay. All right. Number 13. Negative, positive, negative, positive. So that's -1 to the nth power. Okay. Because if I plug in 1, I get a negative number. 2 gives me positive. So I got the sequence correct. Now I've got to figure out what's going on with this fraction. So it's just 1 in the numerator, 1, 1, 1, 1. So I'm just going to put a 1 there. Denominator, 2, 4, 8, 16, 32. Powers of 2, right? 2 to the first, 2 to the second, 2 to the third, which gives me 2 to the n. And that, whoops, I got to write equals A of n, and then I will be good. Okay, and there's that sequence. Okay. You could also write this if you wanted. Since it's negative first, you can go -1/2 to the n. That also gets you there. Those are pretty similar, you'll notice. So just realize that there might be more than one correct answer in this case. All right, and this is one of them. But it's really pretty similar to what I had. Oops, except it's got to be negative inside there. -1/2. Okay. All right. So next, recursive. Recursive's not as good as explicit. When I have a recursive sequence, explicit, because with recursive, you use the last number in the sequence in the equation. So the A of k represents the last number in the sequence, and a of k plus 1 is this number in the sequence. So they also, whenever you do recursive, they got to tell you what the first number in the sequence is. And then in this example is 4. And then we took the a of k and we subtracted 7 from it. So the sequence is going down by 7 each time. So anyway, that's the way this works. And this is one that students find more complicated, even though it's kind of an easier type of situation. So if I was looking at that exact example, and it said find the first 5 numbers in the sequence, you know, if I plug in 4, because that's the first number, the second number will be 4 minus 7, which is -3. A of 3 will be when I take the -3 and then I subtract 7, I get -10. A of 4 is when I take the -10 and then I subtract 7 again, which gives me -17. And A of 5 will be when I take the -17 and I subtract 7, I get -24. So you see how the problem with a recursive type of formula is, if I ask you what the 100th number in the sequence is, there's no way to do it unless you know the 99th number in the sequence. So that's why recursive is never as good as the explicit, okay? But we still use it. And sometimes the pattern is either so complicated we can't figure out an explicit formula for it, or sometimes this is the only way you can come up with an equation for it, all right? So recursive is important, and that's what it is, and that's why. So this one, a little bit more complicated. They tell me the a of 1, so we want to find what the next bunch of numbers is, the first 5 numbers. So if I take 7 and I plug it in, I already know the first number, 7. They told me right here. There's a gimme on a quiz. Second number, if I plug in 7 minus 3, I get 4, and 4 times 2, I get 8. Okay, and the next one, if I take 8 minus 3, I get 5. 5 times 2 will give me 10. If I take find the fourth number, if I take that 10 and plug it in, 10 minus 3 is 7. 7 times 2 is 14. And then if I plug in the 14 here, 14 minus 3 is 11. 11 times 2 is 22. And there are my first 5 numbers in that sequence. Okay. This one, similar. They told me the first number. I'd like to know the second number, third number, fourth number, and fifth number. So they gave me number 1. So if I plug in 10 here, 4 times 10 is 40. 40 plus 3 is 43. Second number, if I take 43 and plug it in, yeah, they start getting big. 43 times 4 plus 3, I'll end up getting 175. If I plug in the 175 times 4, and then add 3, you'll get 703. And if I take the 703 and plug it in, multiply it by 4, and add 3, I'll get 2,815. So that one got big pretty quick, but once again, it's really not too bad a formula to work with if you just realize that, you know, this represents the last number in the sequence, and this represents the number you're working with, this number in the sequence. Okay? All right, so that is all I got for today. I'm stopping there. Have a great night, and I'll see you all soon.